Hello and welcome to today's video for atomic structure topic. Alright, so in this entire series of videos guys, we will study the structure of atom, and particularly in today's video we'll talk about the following learning objectives. Number 1, the Dalton's atomic theory. Number 2, J.J. Thomson's discovery of electron and his experiments. Number 3, Rutherford's gold foil experiment. Alright guys, so let's quickly start with the first topic, which is Dalton's atomic theory. So in 1803, John Dalton proposed this theory guys because we did not have the state-of-art equipments or technology like we have today to actually magnify a particular object and see the atoms and see their structure. So entire discovery on this topic was done on the basis of experiments. So following are his pointers, guys. First thing his atomic theory suggested was all the matter around us is made up of very tiny particles, and these tiny particles are called atoms, and these atoms are indivisible. Now, with this, we also have our today's interesting fact, guys, and the interesting fact for today is yes, the term atom was coined by Democritus, and it meant in that language uncuttable or undivisible. So that was the interesting fact in this video, guys, about from where we got the word atom. Now I give you like a assignment, and I want you guys to find out who coined the term molecule. All right, if you are able to find, do comment below in this video. Alright guys, let's continue the topic. So we're talking about the Dalton's atomic theory, and we already discussed the first point. He said all matter is made up of very tiny particles called atoms, and these atoms are indivisible. For example, the real life example to my students, if we take a sharp pencil and we put a point or a dot from that pencil on the paper, in that one dot, small dot, we will have millions of carbon atoms, guys. So that is the scale at which we can understand how tiny or small atoms are and how difficult it was in that time in 1803 to figure out the structure of atom. Alright, so what was the second point? The second point of Dalton's theory said that all elements are made up of same kind of atoms. That means if you take iron and you observe it in a microscope, you will see all atoms of iron are same. However, if you take copper and you compare the atoms of copper and iron, you will see that they are very different. So that means elements are pure substances because they are made up of same type of atoms. And the atom of one element is different in its mass and structure from the atom of another element. That's the second point. The third point of the theory is compounds are made up of atoms of two or more elements combined in a fixed or definite ratio. For example, carbon monoxide shown here this is an excerpt from a movie made by IBM, guys. The movie is about the boy and his atom. It talks about it kind of depicts the structure of an atom at a very micro level. So here in this particular movie, scanning tunneling microscope is used to magnify the molecules of carbon monoxide up to 100 million times. And that's how this is the image we see, guys. For the full movie, the link is here in the screen. You can go and watch the full movie, guys. Alright, and then the last part is during chemical reactions, atoms rearrange to form new combinations or compounds. So that was the very first theory about the structure of atom. Now the second objective is J.J. Thomson's experiment. So in 1897, J.J. Thomson performed an experiment taking the idea from Crookes' experiment, and he took a gas in a cathode in a tube, discharge tube we call it in chemistry, and this gas was at a low pressure and electric plates were taken to provide high voltage charge across this gas. When this was done, guys, Thomson observed a specific set of rays emerging from the cathode, and he called them cathode rays. So later on, when he extended the experiment, he found that cathode rays are the beams of fast moving electrons. With a very simple argument, What he did is he put two electric field plates, positive and negative, across the cathode ray tube, and he saw that the cathode rays got attracted or deflected towards the positive plate. So that showed that the particles that make cathode rays are themselves negative. That's why they got attracted to the plate. And based on his further studies and research, he came up with a Thomson's plum pudding model of atom, the first model of atom, guys. Though this model was very far from the real structure of atom, but it gave some idea or a stepping stone in this regards that atom also has its own structure. So the Thomson's plum pudding model suggested that the background of the atom is all positive, plus charge, and the negatively charged particles are embedded on it like the dates on a plum pudding. However, with later experiments and discoveries, this model was kind of rejected. Next experiment in this series was done by Rutherford, and he performed the gold foil experiment in 1905.